Hi guys, this is Mr. Urrego, and today we're learning how to condense logarithmic expressions. We have three examples because we have three properties. My first property is the product property. So as we saw on the expanding video, link in the description, when I have a product, it's going to expand as a sum. Therefore, if I have a sum of two logs with the same base, it's going to condense as a product. So therefore, I have log on the same base of x times y, the product of my arguments. Quotient rule. If I have a log of a quotient, a division is going to expand as a subtraction. In my case, the subtraction or the difference of two logs, it condenses into the division of the two arguments. Meaning, I have log on the same base, and now, because it's a difference, I have a 3 over x. Last one. I see a number in front of my log function. In this case, this is natural log or natural logarithm. ln, different ways we pronounce it. Because that's a number in front of it, this technically is an exponent of the argument. Therefore, how to condense that is by having ln of x to the second power. And those are the basic three properties. Let's play with them. Let's say that I have this. I have a 2 in front of my function, or my logarithmic function, and then I have a natural log of x plus 1. First, I need to condense my exponent. So that's my first step. So I'm going to have ln of x to the second power. Now that I condense my exponents, the next step is, I have a plus. That means that's a product. Therefore, I have ln of the product of the two arguments, meaning, let's put a bracket right here, and I have x squared times x plus 1. Okay? You can distribute, not necessarily, but you can distribute that, and it's going to give you x to the third power plus x squared. Let's do another one. Now we have this problem. We have log on base 4 of 2 plus log on base 4 of 32. It's a sum, therefore it's a product. Okay? So I have log on base 4, same base, I keep the same base, and now this is a product of those two, which I have 2 times 32. Now, can I solve that? Yes. So that's going to give me log on base 4, 2 times 32 is 64. Can I keep going? Yes. Remember, we have properties of logarithmic expressions, so check them in the description for that video. 64. 64 is the same as 16 times 4, which is, so therefore I have 1, 2, 3, so 64 is the same as 4 cubed. So I want to replace that. So instead of having 64, I'm going to replace by 4 cubed. Okay? Using the power property, that 3 is an exponent, comes here. So I have 3 log base 4 of 4. If my base and my argument are equal, then this turns into 1. Therefore, I have 3, and this turns into 1. My final answer, 3. What about I have something like this? Log of 200 minus log of 2. There's no base. That means we have base 10. Keep that in mind. There's no base 10. So first of all, I have a difference, a subtraction, therefore that's a quotient or a division of log of 200 over 2. Okay, because I'm able to simplify that, I'll simplify that. That's going to give me log of 100. But remember, if there's no base, we have a tiny 10 right there. Okay, 10, 100. Okay, what does that mean? 100 is the same as 10 times 10. 100 is 10 times 10, which means that's 10 to the second power. Okay, so I'm going to replace the log of this. Is going to give me log of base 10, which I shouldn't be writing because we need to get used to not see a base right there. So as base 10 of 10 to the second power. What happened with that exponent? comes in the front. So I have 2 log of base 10 of 10. But base 10 of 10 becomes 1. And 2 times 1 is 2. So you notice how a big problem turns into something that simple as a 2. Okay? Now let's do a little monster. If you haven't subscribed, please subscribe to the channel. Help me out with the subscription and like the video. Let's go for the monster. Now let's do this little monster. Okay, first of all, exponents. Anything that is in front of my function, of my log, that's an exponent, exponent, exponent. That has to go to the argument as my first step. Okay, so I have log on base 3. That forms an exponent, so it becomes x to the 4th power. Minus, that's an exponent. Log on base 3 of 6 to the 2nd power. That's an exponent. Minus log on base 3 of y to the 1/2. Okay? Now let's work out if there's anything that I can do with those exponents. I do it. Well, x to the 4th? Not really. Minus 6 to the 2nd power. Yes. So 6 to the 2nd power is 36. Minus, I have a fraction as an exponent. That means that's a radical. So log on base 3 of square root of y. Remember, that tiny 1 is here and the tiny 2 is my index. All right. Then when I have got rid of my exponents, it's time to condense. So every time we're condensing, anything that has a minus is going to be on the denominator. So let's condense that in one shot. Log base 3, all of them are the same. Therefore, I have log base 3 fraction. This one's a positive. Obviously, you're going to start with the positive, so that's going to be on the top. Anything that has a minus, my argument goes to the denominator. Minus, my argument goes to the denominator. And then I just put parentheses there just to make sure. And that will be my answer. Okay? To end, monster, monster, monster. It's a little trick, but there's a lot of people that get confused, and we need to see this. To end, monster, monster, like with 10 heads or something like that. Okay, what's the whole idea? I have this 1/3, and I have a big bracket. You see that the bracket is covering everything on the inside. By the way, brackets, parentheses, when you have a parenthesis on the inside, the next grouping symbol should be a bracket. That's the whole idea with the brackets. Let's go back. I have 1/3 bracket. That means that 1/3 is the exponent for the whole thing when it's condensed. Therefore, I need to work on the inside first. Okay, so let's work on the inside. I see a 5 exponent of what? Of my argument. Nothing here, no exponent. Nothing there, no exponent. So let's move that exponent first. I'm going to have 1/3 of ln of x plus 6 to the 5th power minus ln of x minus ln of a difference of squares, which we don't have to do anything with that. Now there's no more exponents. Now I condense. Like the previous problem that we just did, anything that has a minus, it will be going on the denominator. So 1/3 stays, and now we're condensing. ln, same function, ln, ln. Now, here goes my board. This stays on the top. And because I have a minus here, then the argument goes on the denominator. And because I have a minus here, then the argument goes on my denominator. And then I just want to make sure that I have some kind of, grouping symbol right there. And this is the 1/3 on the outside. Now what? This 1/3 will affect my final natural log. Now this 1/3 is an exponent of what? Of my argument. Therefore, what's the final answer here? I have ln of parentheses x plus 6 to the 5th power over x parentheses minus 25 to the 1/3. But what is 1/3? Remember, when I have a fraction as an exponent, that means it's a radical. So let's do the final step. ln, big radical. My index is a 3. Okay? And the 1 is the exponent for the whole thing. Therefore, I have on the inside x plus 6 to the 5th power over x squared minus 25, and we fit everything. The radical covers the whole thing. All right, so what was the whole thing about this problem? That 1/3. Okay, you got to wait till the end and then affect the whole, the condense, when you condense the whole function on the inside. All right, that's it for now. Next, change your base. Okay, it's going to be here or here. Subscribe, like the video. I'll see you in the next one. Take care, guys.